Hello, everyone, and welcome to our third episode of nanoCHAT, NeWBiEs edition, which is the Ionic YouTube series about what it's like to teach a foundation level inorganic chemistry lecture for the first time. My name is Anthony Fernandez, and I am a professor in the Department of Chemistry and Biochemistry at Merrimack College in North Andover, Mass. And this week, I have the pleasure of hosting the discussion between our newbies, Wes Farrell and Shirley Lynn from the U.S. Naval Academy. In the previous episode, the two of them spoke about the first week of class, which was online. So my first question to the two of you is, how'd it go this week being in person?
I think it went well, and I was really excited to be in person to get to see their faces and also to put them together in person to do group work, which was really a big highlight. And in terms of group work this week, I used a couple of different LOs. One involved the Orbitron website. So when we got to sketching orbitals, rather than my sketching them and then copying them down, I said, okay, well, you go ahead and sketch them. And then we clicked through all the different views of the electron density, and it was really, really fun to do that. And they worked really well together in groups. I also used periodically periodic. And I think Wes is going to share some things about how his implementation went. But I know that they worked very efficiently. And then we're getting towards the end of class, and it was on the last day of class for this week. So I teach Monday through Thursday. And so yesterday we were doing periodically periodic. And right at the end, with like 5 minutes to go in class, they started packing up. And I was kind of like, oh, this is a good reminder to me when doing group work. I should bring them back together at the very end so they're focusing on the same thing, and I can just sort of close out class that way. So a little reminder to myself.
And then Wes, did the week go okay for you as well?
Yeah, I thought it went great. Like Shirley said, it was great just to see them in person. There's a bit of a trade-off. I'm seeing them in person, but I'm only seeing their eyes. So, that's a bit of a trade-off, I guess, but it is much better than being the virtual format. But yeah, I thought it went pretty well. We're talking about periodic trends, atomic structure. And what I find interesting is that they already know some of this from their plebe chemistry, which is freshman chemistry class. But I think we're going a little bit deeper, and they're getting a better understanding of it and starting to really think about these things the way professional chemists would be doing so. And the evidence I have for that is anecdotal, but I did hear one of my students who tutors the freshman students saying that she's like, we're covering the same things that I'm teaching my students, but now I feel like I actually know why. So that was pretty rewarding. I feel like she's actually now kind of grasping the more fundamental aspects of electronic structure and then seeing how they apply to these periodic trends and the exceptions to them as well.
Well, that sounds great. And then Shirley, in terms of the content, how did it go in your class, or in your section of the class, excuse me?
Yeah, so I think Wes is slightly ahead of me in material, but I think the periodic trends were a good place for discussion and the ability to just talk about some of these really tricky things. In terms of electron configurations, which we also covered, there's a lot of anxiety by the students about the exceptions. And I tried to say, it's less important to me that you know off the top of your head which ones are exceptions, rather than if I show you an exception, you could explain why that exception may have occurred.
Yeah, and I tried to do the same with my students in my section. Is they would think like, oh, do I need to memorize the fact that gallium is abnormally small? And I tell them that's not really what we're doing. I would much rather you explain to me this odd phenomenon, which is why I did the periodic activity too. And I thought it was so great because in listening to them talk about it in their small groups, then when we talk about it together as one large group, they're thinking about these things when we're really thinking about the electronic structure that gives rise to these trends. So it's basically taking what we've done before and allowing them to really kind of delve into the weeds about it.
So Anthony, one of the challenges I had in covering the material was that we spent a reasonable amount of time talking about the kind of abnormal filling when we get to the 4S 3D. And I don't know that I did a good job at all really talking about, other than to say it's complicated. Those orbital energies are close, and the electron repulsion matters. But I'd love to hear, how you approach that.
Well, so this is a topic, Shirley. I've taught inorganic chemistry now, I think 20 times over the course of my career. And this is always a challenging topic. And if you follow any sort of chemistry groups on Twitter or on Facebook, this question comes up with some regularity. And when we talk about the ordering of the 4s and the 3d orbitals, it seems that there is a contradiction, right? Where you fill in one direction, but you take out in the opposite direction, and it doesn't really seem to make sense. And the way that I always go and talk about this with my students is I say, look, is that we're trying to explain what goes on, and we have these explanations that aren't perfect. And I try to say, well, we told you this before, but we kind of lied to you just a little bit, right? And then now let's talk like chemists, right? That we have uncertainty. And when we think about orbital energies, we tend to think about them from the perspective of them being empty. And of course, we calculate orbital energies for hydrogen, which is not a transition metal, right? And then when we put electrons in there, we also have repulsions going on. So then you start to change orbital energies. And so I try to say is that when we fill in there empty, there's one trend that we follow. Once they're filled, we change those orbital energies slightly, and then we have to do things a little bit differently, right? But I don't think there's one perfect answer to this question. But the point that I try to get them all to is that in the end, when we look at the valence electrons in transition metals, at least, that they reside in the 3D. And so that's the point that I really try to herd them towards. And I do whatever I need to sort of get them to that point. And then now, did the two of you run into that? How did you go and address that issue if it came up?
Didn't really seem to come up with my section. I'm not entirely sure why that is. Maybe they just didn't want to ask the question because they'd be afraid of the answer. They just kind of took it as fact that what I told them in terms of the energies, I explained to them the best of my ability why this ordering is a little abnormal, and they kind of just took it as gospel. So I'm not entirely sure. Maybe I should have done a little bit more assessment there now, thinking about it, to see if they could explain that back to me. I should have added it on to one of the problems, but we'll have plenty more time to address it.
Sure.
I think we're both intending on giving our first quiz next week, and that'll be that'll be eye-opening, I think, in terms of what we think the students are getting versus what they're able to then show us they know and can do.
Sure.
Yeah, I'm very excited to see how they do in that first quiz next week. And depending on how fast we're able to grade it, we might be able to share that with the people watching this video as well.
And will that quiz go and focus on these topics that you feel they all should have learned elsewhere? Or are there any topics on that quiz that will be entirely new to them?
I think it's going to be mostly new. It's going to be a lot asking them to show a deeper understanding of the wave functions of these orbitals, know much more about penetration and shielding than they would have otherwise known. So I think it's going to be mostly new. I mean, they might have heard the words before in another class, but it's going to be focusing on newer material, I think.
Yeah, I agree. It's so some of it, like just writing electron configurations, they did a lot of in Gen Chem, and hopefully they remember doing it. But then, for instance, I had not really been taught radial distribution functions before, so that was new to me. And then to teach it and really help them see all the structures where are the nodes and why there are this many nodes of this type and that many nodes of another type. I thought that was really, really eye-opening just to me. And to be able to draw the pictures was helpful.
Well, that really is great. It sounds like you had a really good week, and I hope that you're able to share your results in the next episode. And so I think that at this point, I just want to thank you and Wes for taking part in this great conversation. It helps me to think back to so many years ago when I went through this for the first time, right? And I would also like to thank those of you who are watching this online. We invite all of you to continue this discussion on our Discord channel called the Viper Pit. And we hope that you will go and follow this conversation with our newbies in the future. And so with that, I hope you all have a great week. Thanks, everyone.
Thanks.
Thanks.